All right, let's continue with question 2. The figure below shows a two-stage gear reducer. Identical pairs of gears are used. This enables input shaft A and output shaft C to be collinear, which facilitates machining of the housing. Shaft B, called the counter shaft, turns freely in bearings A and B, except for the gear tooth forces. A, determine the RPM of shafts B and C, the pitch diameters of the pinion and gear, and the circular pitch. All right, so here, if you look at the question itself, this is the shaft which is connected to the motor. It rotates the shaft and the gear, the pinion itself rotates with 1200 RPM, and we have 1 kilowatts of power, and the pinions have 15 teeth with diametral pitch of 5 and angle of pressure of 25 degrees, and the gears have 45 teeth. Part A. We need to find RPM of shafts B and C, the pitch diameters of the pinion and gear, and the circular pitch. All right. For the RPMs, we know we have this formula. A and B refers to the shaft, so this is A and this is B, and this N refers to RPM, and this N, capital N, refers to number of teeth. We know what is the number of teeth of A, the gear on A, shaft A, and the gear to be exact, the pinion on shaft A, which is this one, and the number of teeth on gear on shaft B, which is this one, and we know the rotation of shaft A, which is 1200. So what we need to find is NB. I rearrange this equation, so NB should be equal to NA over NB times NA. So from here, how many tooth in shaft A? I mean, in the gear which sits on shaft A, it is 15 over 45 times 1200. So 400 RPM or revolution per minute. How about C? So this gear and this pinion, they both rotate with RPM of 400 RPM, and we need to use same formula to find the RPM or RPM of shaft C. All right, so NC over NB equals to NB over NC. For this formula, don't forget we have A here in the denominator and numerator, and vice versa for B. So from here, we've got the number of teeth, we've got NB, so we need to find NC. NC equals to NB over NC times NB. So number of gears on shaft B, or pinion on shaft B, which is 15, over number of teeth on gear which sits in shaft C, which is 45, and times 400. So again, NC should be equal to this RPM, or again revolutions per minute, or 1 per minute. Okay, we found the RPMs. Next, what we need to find is the pitch diameters and the circular pitch. All right, we know that diametral pitch equals to n over diameter. And what else do we know? So from here, diameter should be equal to, I rearrange it, so it should be equal to n over p. So what was the number of teeth? So it depends actually. So we can say for pinion and for gear. For pinion and for gear. So for the pinion, we have 15 teeth. And what was the diametral pitch? Have a look at the question again. It was 5 over 5, and it's teeth per inch, the unit. So it comes down to 3 inches. How about the gear? We have 45 teeth. Same diametral pitch. So should be equal to 9 inches. All right, we found the diameter as well. And circular pitch. We know that circular pitch, what was the equation if you remember? Pi over pitch. So what was the pitch? 5 diametral pitch, so it will be equal to 0.63 inches.